Okay, so this is question number 13 from SS KROTOV. So, hi everyone. Let's start with the solution of this question. Before getting directly into the solution, I would suggest that give it a try by yourself. This is a very good question. Anyway, so yeah, let's start with the solution of this question. Okay, so let's assume that initially the piston is at a distance x1 from this side, and after we have given a small amount of heat to this whole system, the piston gets shifted by some distance, and the final, the position of the piston from left hand side is x2. Okay, so now we are supposed to find the heat capacity. We assume that friction is absent everywhere. Okay, so yeah, let's start with the solution. We have been given that on the left hand side there is 1 mole of gas. All right. Yeah. So now if we give a small amount of heat to this system, there will be a sort of temperature rise from x1 to x2. We say that the temperature when the piston was at a distance x1 was T1, and when the distance comes out to be x2, the temperature is T2. Now, since there is 1 mole of gas, so we can directly say that dq equals to C into dt. The dt is nothing but a T2 minus T1. All right. Now, okay, let's start with the first law of thermodynamics. So dq equals to the change in internal energy of this gas, all right, plus the gain in potential energy when the piston moves from distance x1 to x2, and that is nothing that is but that is half k x2 square minus x1 square, all right. And now this delta u is very easy to find. Okay, this delta is nothing but it is equals to 3 by 2 r T2 minus T1. All right, that is equals to 3 by 2 R dt. N is 1 again, since there is 1 mole of gas, so we assume N to be 1 and we get this result. Okay, now we are more concerned of getting this expression like this half k x2 square minus x1 square in terms of dt and all, so that eventually when you put dq as c dt, the terms dt would be eventually be cancelling. Well, let's jot down to this expression. Now um, we can write PV equation for x1 and x2. Now listen very carefully. How am I writing this? Okay. Now when x1 is the coordinate, okay, of the piston, we start by writing pressure volume equation. That is pressure, that is force kx1 by area. Let's assume the area of cross section of the piston to be S. Pressure into volume. Volume is nothing but S into x1 divided by nr. N is 1 again. So it's R is equals to T1. So S gets cancelled. Kx1 is equals to RT1. Similarly, we can write Kx2 equals to RT2. Alright. Sorry, it's Kx1 square and Kx2 square. So now half K x2 square minus x1 square will come out to be as r t2 minus t1 by 2. It's very simple, right? Eventually, we're coming down to the conclusion as dq is equals to delta u. Delta is nothing but 3 by 2 r dt. Let's write it down, 3 by 2 r dt plus this expression half k x2 square minus x1 square that we have evaluated out to be r delta t by 2 r dt by 2, that is 2r dt. Now we can write dq as c dt. Again, dt dt gets cancelled and c equals to r. Okay, the main task was, how can you, just jot down this form into terms of dt and r. Okay, I hope you like the solution. Thank you.